Hello my dear friends, let us continue learning. Probably in the last session you have learnt the selection sort algorithm, you have implemented the selection sort algorithm by using Java programming language also. Now in this session, you will have to understand about something called as insertion sort algorithm. First, let us read the program. This is the program that they are asking. Write a Java program to sort the contents of an integer array in the ascending order using insertion sort algorithm, it seems. There the question is not ending. They are asking you to write a method called as insertion sort and keep all the insertion sort algorithm statements inside that. They are specific in telling that the insertion sort method should accept the integer array as parameter and it should return void, it seems. That is what is the question pretty much is telling. Sample output also is given. Now what you have to do is just pause this video and copy this question as it is. Pause it. We'll continue now. See, sorting is the process of arranging the elements either in ascending or descending order. Bubble sort we have learnt. We have arranged the elements in ascending order. Selection sort also we have learnt and we have arranged the elements in ascending order. Now it's time to learn something called as insertion sort. If you ask me, sir, what is insertion sort? How the algorithm goes? Bubble sort, probably I have explained the working first, then I have given the algorithm. Selection sort, again I have explained the working first, then I have given the algorithm. Now also I can explain the working first and I can give the algorithm. But just to prove you that I can give the algorithm and explain, it would not make any difference provided you know how to read an algorithm. To explain this part, first only I will give off the algorithm. Most of the students would be worried, sir, if you give off the algorithm, will we really understand? By the end of the lecture, more than me, you will be telling the algorithm. Carefully watch it. See, this is how the insertion sort algorithm goes. You have to start again. How I am reading, how I am writing. Concentrate more on that, complete clarity you will get. You have to start from I equals to 1, it seems. You have to go until I less than or equals to n minus 1. Every time you have to increment the value of I. Initially, whatever is there in that array of I, you have to give it to a variable called as item, it seems. And you have to place j one level before I, it seems. After placing j one level before I, you have to enter a loop. Means, which loop, if you will ask me, as long as loop. Look, as long as this j is positive and this array of j is greater than item, I have to push that array of j one level below, it seems. Not only that, I have to decrement the value of j, it seems. Once I come out of this loop, as long as loop, whatever is there in item, I have to give it to array of j plus 1, it seems. This I have to do from I equals to 1 to n minus 1, it seems. Sir, nothing we understood, sir. Literally nothing we understood. What is this, sir? For I is equals to 1, I less than equals to n minus 1, I plus plus, item equals to a of I, j equals to I minus 1. As long as j is positive and a of j is greater than item, push a of j one level below, j minus minus. A of j plus 1 equals to item. What is this, sir? That is what I am telling you. If you read it like that, you will not understand. Again, I will read the algorithm. Listen to the words carefully, whatever I am using. If you listen to the words carefully, algorithm will become simple. Start from I equals to 1. Go until I less than or equals to n minus 1. Every time, whatever is there in a of I, that you give it to a variable called as item. Place j one level before I. As long as j is positive and a of j is greater than item, push a of j one level below and decrement the value of j. Once you come out of the loop, then whatever is there in item, give it to a of j plus 1. Sir, even now nothing we understood, sir. Watch it. Say supposing you have the array elements like this: 86, 42, 23, 18 and 25. This is array. I know, sir. Array till now you have represented it horizontally. Why, sir? Vertically you have represented. However, I will represent. How does it matter? To make the concept clear, I am representing it vertically. That's it. Apart from that, if you will take this array and turn like this, what big difference it will make? Nothing. Just to make the concept clear, I have written it vertically. Now let us start the algorithm. What the algorithm is telling? Start from I equals to 1. Look at it, how easy it is. Look at it. Start from I equals to 1. Go until I less than or equals to n minus 1, we will see it. Take whatever is there in array of I. What is there in, see, first of all, what is I? Correctly tell me what is I? I is 1. What is array of I? Array of I is 42. I is 1. Array of I is 42. So what they are telling? Whatever is there in array of I. Oh, what is there in array of I? 42. Give it to a variable called as item given. Place j one level before I. I is here. I am placing one level before I. Place j one level before I. Done. Enter the loop. As long as j is positive. What is j? 0. J is 0. As long as j is positive. Is 0 positive? Yes, 0 is positive. As long as j is positive and array of j, what is array of j? 86, is greater than item. What is item? 42. As long as j is positive and array of j is greater than item, I is greater, both conditions are satisfying, push a of j one level below. A of j one level below I have to push. Oh, okay, pushed. Decrement the value of j. J becomes minus 1. As long as j is positive and a of j is greater than item, push a of j one level below, decrement the value of j. Done. You are inside the loop. You go back. Again check. As long as j is positive, as long as j became negative. If j becomes negative, then this condition would fail. Always remember, it is AND condition. Both conditions should pass. So if one condition fails, it is failed only. Control will come out of the loop. If control comes out of the loop, whatever is there in item, take it and give it to a of j plus 1. Whatever is there in item, take it and give it to a of j plus 1. 42 will come here. As of now, array contents are like this: 42, 86, 23, 18, 25. I previously was 1, now I will become 2. Again continue. Whatever is there in array of I, give it to a variable called as item. Now things will become easy, you see. Place j one level before I. Enter the loop. As long as j is positive, yes, 1 is positive, and a of j is greater than item, a of j is 86, 86 greater than 23, correct? A of j is greater than item, push a of j one level below. Okay, pushed. Decrement the value of j. You are inside the loop, go back. As long as j is positive, j is positive, and a of j is greater than item, correct, a of j is greater than item, push a of j one level below, pushed. Decrement the value of j. As long as j is positive, j became negative. Control will come out of the loop. As soon as control comes out of the loop, whatever is there in item, take it and give it to a of j plus 1. 23 will come here. As of now, the array contents are 23, 42, 86, 18, 25. I previously was 2, now I would become 3. Again continue. Whatever is there in A of I, give it to a variable called as item. Place j one level before I. Enter the loop. As long as j is positive and A of j is greater than item, push A of j one level below. Pushed. Decrement the value of j. As long as j is positive and A of j is greater than item, it is greater, push A of j one level below. Pushed. Decrement the value of j. As long as j is positive and A of j is greater than item, yes it is greater, push A of j one level below. Pushed. Decrement the value of j. As long as j is positive, j became negative. Just because j became negative, you will come out of the loop. Whatever is there in item, give it to A of j plus 1. Okay, given. As of now, the array contents are like this: 18, 23, 42, 86, 25. I previously was 3, now I will become 4. Look at it. Now I will become 4. Initially, whatever is there in array of I, 25, take it and give it to item. Place j one level before I. Enter the loop. As long as j is positive and A of j is greater than item, it is greater, both condition passed. Push A of j one level below. Pushed. Decrement the value of j. As long as j is positive and A of j is greater than item, push A of j one level below. Decrement the value of j. As long as j is positive, A of j is greater than item. J is positive, but A of j is 23, it is not greater than item. Again one condition failed. This condition passed, but this condition failed. Because it is AND, both conditions should satisfy if control should come in. If one condition fails also, control will come out. So, j is positive, but A of j is not greater than item. So, you come out of the loop. As soon as you come out of the loop, what are you doing? Whatever is there in item, give it to A of j plus 1. Okay, 25 will be here. 18, 23, 25, 42, 86 and stop the algorithm. If you ask me, sir, why we have to stop? Why? Because I should start from 1. I should go until n minus 1 only. We have come to n minus 1. Stop it. If you will stop and see the array, 18, 23, 25, 42, 86, sorted, no. Initially it was like this. 86, 42, 23, 18, 25. Now it is like this. Array is sorted. Algorithm is very, very simple. If you will know how to read it and whatever you are reading, how to do it. This much if you know, algorithm is very, very simple. Now, again shall we read the algorithm now? Everything will make sense. Start from I equals to 1. Okay. I less than or equals to n minus 1. Every time whatever is there in array of I, take that as item. Place j one level before I. As long as j is positive and A of j is greater than item, push A of j one level below. Decrement the value of j. You have to do add this again and again and again until both the conditions are satisfied. If any one condition fails, you will come out of the loop. And whatever is there in item, you will give it to A of j plus 1. This if you will do it from I equals to 1 to n minus 1 like this. Array elements should be sorted. I hope I am completely clear about the insertion sort algorithm also. Knowing the algorithm or telling the algorithm or keeping the algorithm in mind is very, very important. It is really very important. Bubble sort algorithm you see. You remember bubble sort algorithm? Start from the first iteration, go until n minus 1th iteration. In every iteration, start from first comparison, go until n minus 1 minus ith comparison. Like that you did. Every time check if A of j is greater than A of j plus 1. If it is greater, then swap. Else don't swap. Continue like this until all the iterations you will get the sorted array. When it comes to selection sort, Start from I equals to 0. Whatever is there in array of I, take it as minimum. Its position present in I, give it to POS. Then really which is minimum, to search that, appoint one servant called as J, one step ahead of I. Search for the real minimum by comparing whatever is there in A of J with minimum. If A of J is really less than minimum, give A of J to minimum, its position which is present in J to POS. Like this you do every time starting from 0 until n minus 1. N minus 2. If you will do it, then you will get the sorted array. Of course, if J falls down from the array, you have to swap whatever is there in array of I and array of position. That much algorithm is present in your mind, you can write off. The same thing is this also. Start from I equals to 1, go until n minus 1. Every time take whatever is there in array of I and give it to item, place J one level before I. Enter the loop as long as J is positive and A of J is greater than item, push A of J one level below, decrement the value of J. Once you come out of the loop, whatever is there in item, give it to A of J plus 1, work is over. Any algorithm for that matter, if you know how it works, writing the algorithm, converting it to code is very, very simple. For the final point here, this you will write off programmatically, this you will write off programmatically, this you will write off. What is this push A of J one level below? How to write it programmatically? You only see, whenever I pushed the A of J one level below, what I did? Look, here also I pushed the A of J one level below. Here also I pushed A of J one level below, A of J one level below. What did I do? Nothing pretty much. Whatever is there in A of J I have taken, 86, and I have given it to A of J plus 1. Am I not correct? Here also you see, J was here. Whatever is there in A of J, 86 I have taken, given it to A of J plus 1. If J is here, whatever is there in A of J I have taken, given it to A of J plus 1. Here also, whatever is there in A of J I have taken, given it to A of J plus 1. That is what is pretty much pushing A of J one level below. So if I will remove this and write programmatically, what is pushing A of J one level below? It is nothing but giving whatever is there in A of J to A of J plus 1. This only is pushing A of J one level below. That only pushing A of J one level below is. Now it is that from 2-3 sessions you are converting algorithm to codes. First what you have to do now is copy this working. Copy this logic. This logic also you copy. Once you copy the logic, try to convert this logic to working program by reading that question. Question is given to you. By reading that question, try to convert this logic to fully working insertion sort program. Let me see how many of you will do it. Until you do it, please try it. If at all somewhere you have stuck and you cannot go ahead, then only continue the video, watch the program, then come to conclusion. You have to put in 100% effort to convert this logic to the working program, like however we have converted the selection sort. Try it, let me see. Be quick. Okay. I hope you have completed the conversion of that logic to the working program. Whether you have converted properly or not, just cross check here. Well, according to the question they have asked, I have to write one insertion sort method which would accept one integer array as input, which would not return anything, it would return void. Inside that, the insertion sort algorithm statements have to keep. But that insertion sort algorithm, insertion sort method, I have to keep it inside a class now. So I will write one class called as sorting. Inside the class sorting, I have public static void, I have one method called as void insertion sort, like this. This is void insertion sort. Now they should accept one integer array, probably A. You have the array, you have to sort the contents of that array in the ascending order by using insertion sort. So what I will do is I will have one variable like this, item. Not only that, one more variable called as j also I would have. What is algorithm? You have to start from I equals to 1. You have to go until I less than or equals to n minus 1 or array length minus 1, I plus plus. Whatever is there in array of I, initially you have to give it to item. Place j one level before I. That is what you have to do. Next, as long as. That is what is as long as while. So, as long as j is positive, that is what is j is positive. If any number is greater than 0, greater than or equal to 0, that is positive number. So, as long as j is positive and a of j is greater than item, what should I do? I have to push a of j one level below. How will you do it? Push a of j one level below. Decrement the value of j. Once you come out of this loop, whatever is there in item, take it and give it to a of j plus 1. That is the opening of the for, this is the closing of the for. That is the opening of the method called as insertion sort, closing of the method, closing of the class called as sorting. Method is ready, but I have to take the input from the keyboard. That input I have to keep it inside the array. That array I have to pass here so that he will perform sorting in the insertion sort way. All those things I will write in the main method, and main method I will keep in a class called sorting app. Inside this, I have public static void main, which would accept the string of args inside the main method. Inside the main method, probably because I have to take the input from the keyboard, scanner. Scan equals to new scanner of system.in. Next, I would tell to the user, I would tell system.out.println. Enter array length. By seeing this message, the user will enter array length. I would collect it by telling scan.nextInt. I would store it in a variable called as n, which is of type integer. Array length is there, array is not there. So what I will do, I will call JVM wake up. I need a new integer array of the same length entered by user, which is stored in n. For that, give the name as ARR. ARR is an array of type integer. Done. Array is there, inside that elements is not there. So I would ask the user system.out.println enter array contents. By seeing this message, user will enter the array contents. I will collect it by telling start collecting the array contents from I equals to 0, I less than or equals to array.length minus 1 I plus plus. Every time I would tell system.out.println what to print. Enter a number. By seeing this message, user will enter a number. I would collect it by telling scan.nextInt, and I would store it in a variable, I would store it in an array of ith index, closing the for. Array elements are there. How it is there before sorting, that also I would print off. Array elements have collected. How user has entered before sorting, I would print. So here I would tell system.out.println array contents before sorting. That is what I would tell. Probably how the array contents are there, like this. Start printing the contents from I equals to 0, I less than or equals to array dot length minus 1 I plus plus. Here I would tell system.out.print. What to print? Whatever is there in array of I plus 1 space. Now I have to sort. After that I have to print the sorted one. It should come in the next line. So what I would do, here I will tell system.out.print ln. That is what I would tell. Okay sir, next what? I have to sort the contents of that array by using insertion sort algorithm. That is present here. If I will give that array to this fellow, he will sort it in the insertion sort manner. He will give back the array to me. So I have to call this method. If I want to call this method, I have to create the object of sorting. Like this I would tell. Watch it. Sorting. Yes equals to new sorting. And I would call that method. Yes dot insertion sort. Now I have to pass that I have to pass that array, ARR I would pass. What would happen? As soon as you call a method, control will go to that place wherever body of the method is written, control is not coming, he is bringing the address of the array. That address would be collected in A also will point to same array. There the contents would be arranged in the sorted order. Control would come back. Means sorting is over. Probably I would print the contents like this. System.out.println array contents after sorting. Here I would tell start printing the contents from 0th index, go until array.length -1 I plus plus. Inside this I would tell possibly system.out.print. What to print? Whatever is there in array of I plus 1 space. This is the closing of the for, that is the opening of the main method, possibly closing of the main method, opening of the class called as sorting app, closing of the class called as sorting app. Like that, if you will see, almost in the approach of selection sort only, we have written the program, but algorithm is insertion sort only. This is insertion sort algorithm. I hope 90% of the students would be successful in writing this code after listening to so many days of lecture. Will it really work? Might be your question. Probably we'll open the Eclipse. We will right click, run as Java application. Probably I would give the input as 86. I'm sorry, enter array length it is asking. I would give the length as 5. Enter an element 86, 42, 23, 18, 25. As soon as I click on enter, before sorting array elements would be printed. Sorting would happen. After sorting array elements would be printed. Enter, printed. I hope I am completely clear about the insertion sort algorithm, how it works and the program. Now we have two assignments, or I can tell two major assignments. The first one, bubble sort, selection sort, insertion sort. All this is sorting the elements in the ascending order. That is what we have seen. You have to change this algorithm such that it would sort the elements in the descending order. That is the first assignment. If you have 10% of common sense with respect to technology, you would do it. Wherever you have lesser than, there greater than should be done probably. Wherever you are searching for the minimum, there you have to search for the maximum, probably. Wherever you are checking lesser than item, probably you will have to check for greater than item, probably, or wherever you are checking for greater, you have to check for lesser, whatever it is. Do this minor changes of greater, lesser, minimum, maximum, you would get the output. That is a hint I can give you. Try converting all these algorithms such that it will sort the elements in the descending order, first thing. Second thing, that bubble sort, linear search, binary search. You remember? 3 algorithms we did: bubble sort, linear search and binary search. All those 3, we did not write it in this approach, means linear search algorithm keep it in a separate method, binary search algorithm keep it in a separate method, bubble sort algorithm keep it in a separate method, take the inputs in the main method, give the inputs to that method. In this approach, we did not do 3 things: linear search, binary search and bubble sort. You have to convert those algorithms to this approach. That questions also you would get in the next slide probably. Like how you have written a big question for the selection sort, insertion sort, like that big questions for linear search, binary search and bubble sort you would get. Copy the questions, write the programs which will actually be in this approach. So 2 major assignments: descending order for bubble sort, selection sort, insertion sort. Second one, that linear search, binary search and bubble sort, you have to write the program in this approach. Try it. If you will not try, if you will not do the assignment, simply watch the video and go off, you are in the wrong track. You will never become programmer. IT industry is not to such people who will just look, listen, go. You have to work, you have to research, you have to program. 90% I have taught you, 10% at least you have to do. That is when you will become programmer or coder. Or otherwise you will be student only. I will be teaching, you will be learning. You are student, I am teacher. When will you become programmer? When will you become coder? Try all the things whatever I have told you. Copy this program as it is. Then the next slide will bring you 3 questions. Copy the questions. This session I would be stopping it here. We'll meet you in the next session. Until next session, please do take care of yourself. Happy coding and goodbye.